Let us see some of the real world uses of these graphs and in what domains are these mostly employed. So the first is the social media such as Twitter, such as Facebook, such as LinkedIn. And here we identify groups or communities and group interactions. So that's what we're trying to figure out whether a certain set of people are in close collaboration with one another. If some scheme is running on Facebook or let's say Twitter, such as this Black Lives Matter that we recently had. So, what people are most involved in it, what people are most active, find the influencers in the community, who has the most number of followers and is more likely to say anything that would be followed or bring about any change. Then, what are the topics of interest that are running between people these days? What most people are hashtagging about or talking about. So all of those are usually the part of the social media analysis. Okay? And that's what we can do using graphs. This is one of the things that is most happening. You can see that there are Google trends, there are Twitter trends, and these help us see in any case what the direction of anything might be. Okay? So abhi jaise we have the elections, US elections happening, so we see what the opinion of the public is, making full use of this as well. Then biological entities also form a network, and it is really helpful to discover relationships. For example, gene protein relationships, disease to disease relationships. And this analysis can help us understand what the bacterial viral structures are and how to um, best find solutions to them or let's say antidotes to them. These help us finding in anomalies. Geographical systems also use these graphs a lot, ठीक है? Such as smart cities. These would tell you about the coverage analysis, uh, which areas are more congested, which are less congested. In the more congested areas, then you can have some other analysis, such as what is the pollution rate, what is the employment rate, education rate, but then they can help us see what the traffic flow is, congestion estimation, routing information. Okay, so traffic flow can be adjusted on basis of the timings, on the basis of what people require, the different kinds of transportations. Okay, maybe we can create new jobs in the near locality to cater for the traffic flows and congestions. And all of this again would be done if we have a proper geographical map of the system and we can get data from that. Then failure impact analysis, again, if something falls or something breaks, what areas would be impacted, how large would the circle or the area of effect of something. Then predictive maintenance, that's also something that is done by graphs. We in AI and ML such fields, we see that all of the time. That in order to understand the next state or predict the next state, given the current one, we also use this graph theory or graphs. Okay? It helps us compute the probability of the sequence of events. So given the previous events, we see where the next one or coming one will fall. Based on all of these, I can say that graphs are suitable for interaction relation intensive data domain. Every data domain or every part of life in which I require that the interaction, your relationship is given just as much importance as the node itself, then I can use these graphs. Okay? Simply because graphs provide the intuitive representation of such interactions or relations. These are efficient data processing. We do have a lot of algorithms that are optimized to work on graphs, and these are efficient query and analytics. Okay? Since we have very efficient data processing associated with this, so a lot of types of queries can be done, and these queries can also be done in very short time. Okay, so there is a lot of information we can extract, and we can extract that information very quickly as well. This is the reason why graph data structures are used every time we think about or we talk about the relation, yeah, interaction intensive data.